Everyone. I am Tobias Turnström, PM lead in SQL Server Engine, work on T-SQL stuff. And I'm here to talk to you about a little bit about R2, or mostly 2008, and then mostly covering what we did in T-SQL for SQL Server codename Denali. And please, if you have any questions, feel free to raise your hands or yell or something, and then I'll do my best to answer them. Only easy questions, so no hard ones. So first, where do I work? So SQL Server Engine is split into 4 parts as of now, and I work in the app plat team. So we own the top layer of the SQL Server Engine, so T-SQL language, type systems, type system libraries, SQL CLR, these things. And then we have the data processing guys. They own the actual query processor, so query optimization, query execution. Storage guys own the storage engine, backup restore, admin. And then we have the high availability guys who own always on in Denali. So first, just some reminders about what was new in T-SQL in SQL Server 2008. R2 didn't actually have any T-SQL features. It was mostly a BI release. And then we'll jump into the Denali stuff. So, regards to the reminders, so finally, we got separate date and time data types. So there's a new set of data types for handling basically points in time. So date time 2, now has a precision down to 100 nanoseconds instead of every third millisecond. And datetime offset is basically this datetime 2 guy with support for time zones. So time zone where always standard time, always winter time. The merge statement, so that you can actually do upsert delete, right? You say take this set and apply it to this table, and whenever this is true, I want you to insert. Whenever this is true, I want you to update. And whenever this is true, I would like you to delete. And you can do fairly fancy stuff with merge. It also simplifies lots of things. It's a very common query that you get some data and you either want to insert it in or update it. So definitely take a look at merge for that. Grouping sets, I can show quickly. Let's see. So simple query against the sysmessages table. Let's say we would like to get just counts by language ID and severity level. So we'd say language ID, severity, count, and we have to spell correct. Yeah. And then you do this, right? So this everyone knows. Now I'll get the count of rows per language ID and severity level. So what if I would also like to have the count summed up per language? So independent of severity, I'd also want it per language. Today, you could either use with cube or with rollup, which are very kind of static extensions that we're also deprecating, or you could go and do a union all query and do another one, right, where you group by just language ID. With grouping sets, you could say instead, I want to group by grouping sets. And then I specify language ID and severity as one grouping set. So now I get exactly the same thing as the previous query. Then I could just add and say, well, okay, please give me also by language ID and by severity. And I'd also like the total. Oops. And then too much commas. So now I get all of these different aggregations, or the rollup, if you will, produced for me. And I can decide exactly what rollup I would like. So grouping sets, very simple extension to T-SQL, but very, very useful if you produce grouping, or if you do grouping, which I guess most of you do, right? Then we added support for spatial queries through 2 new types, geography and geometry. So geometry is basically a type to handle coordinates on a planar surface, right? And geography is for a sphere. And you can do really interesting queries, including indexing on top of these to figure out what is the distance between these 2 points, do these 2 polygons intersect, things like this. So it's very, very useful. It's pretty cool. You can do lots of things combining this with things like virtual Earth or Bing Maps. And then we also added table-valued parameters. How many in here have used TVPs, table-value parameters? Okay, only maybe 5%, a couple of you. So definitely take a look at this. This makes it possible for you to send basically an array, or a table if you will, as an argument to a batch or a stored procedure, which can be very, very useful if you want to process a large number of rows in just one call to SQL Server. Basically what you do in .NET, for example, you can either use a data table to send, you can also do it streaming by using one of these classes, SQL doobie-doo, something. But it's very, very useful because everything gets sent to the server in a very efficient format as part of TDS protocol, and then just put in a temp table, shows up as a table variable in the procedure in the batch, and then you can go ahead and use it, for example, with the merge statement. Just take this set of 1,000 or 1 million records and just upsert it into this particular table. So really useful and really, really good performance. So that was the quick walkthrough. Now, let's take a peek at SQL Server Codename Delali. How many of you have downloaded the first CTP that we released and tested it? Only, okay, very few. How many of you have heard about what's new in Denali so far? A couple? Okay. So, we'll start with looking at a couple of new things with regards to query and schema constructs. Improved error handling, which is very, very useful. Improvements to dynamic SQL, additional scalar functions that I wonder how at least I could live without before, and robust discovery of result set metadata, which we'll try to figure out what that actually means. So, first, support for simplified paging constructs. So today, how do you actually do paging if you want to fetch rows 1 through 10, 11 through 20, and so on in T-SQL? It's rather cumbersome, right? So let's say here I would like to, again, select from the sysmessages table, and would like to grab rows 1 through 10. I have to produce, there are several ways to do this, but the typical way people go about it is producing a row number column. So I'll produce a row number ordered by, language. Put this in a CTE, common table expression. Then you'd select from that and grab only these rows, where row number between 1 and 10. And obviously, you'd add an order by as well. Yoo-hoo. There we go. So first 10 rows, 11 to 20, next 10 rows, and so on. So this is rather cumbersome, and it's a very common thing that you guys do. It's very, very common that I like to get first 10 rows, next 10 rows, next 10 rows, and so on. So what we did is we added the support for the offset and fetch next keywords to T-SQL. These are parts of the ANSI standard specification for the SQL language. So basically, you just say, hey, offset 10 rows. That means just skip 10 first rows, and then fetch me next 5 rows or next X rows. And we support expressions there. So you could even have a subquery specifying how many rows to skip, how many rows to get. Obviously, use variables or whatever you feel like. So instead of this query, I just have to add the order by clause. Offset 10 rows. And there we go. So definitely a lot simpler. In the plan, we use also different constructs. So this basically shows up as the top operator. Let's see. So there we go. That's the actual top. Why do we get the join here? The sysmessages is a view. That's why you see the join. About stability of this result set, obviously it's not a cursor, right? So if you fetch the first 10 rows and then you wait 5 minutes and then you get the next 10, those could be overlapping. There could be missing rows in between, right? Since there's no state being held on the server side. So this is only fine if you don't require that the stability of the result set be, or the result set be stable across calls, right? If you need stability, you either should get all of the rows into the client or use a server-side cursor. And then we added support for UTF-16. So how many in here know what UTF-16 is? Yeah, I can't really say I really understood it. They have these UTF-8, UTF-16, UCS2. These are different formats for handling more than what we can store in a byte with regards to characters, right? So SQL Server, until Denali, only supports the UCS2 format. So UCS2 format states that every character is represented as a word, that is 2 bytes. Okay, that sounds fine, right? In 2 bytes, I can fit 65,000 and some characters, or different characters. It turns out that that wasn't enough. So you actually need more than these, than 65,000 in order to represent all characters, especially when you get into, like it says here, some music notation, math symbols, ancient characters, and so on. So then what happens? So what happens if you use one of these characters that we can't fit in 2 bytes? Easy, you use more than 2 bytes, right? So use 4 bytes to represent them in UTF-16. So what happens if you take one of these 4-byte characters and shove it in SQL Server? Well, I happen to have one of them here. So first, let's just send it to the server and get it back. And you see that I get back the same character. So I clearly didn't have any corruption, right? The server took the character, managed it, and sent it back. So that's all fine. However, the server doesn't know that this character is actually 1 character. To the server, this is 2 characters. So now if I say, hey, give me the length of this guy, we get 2. And, okay, I'm holding Shift, pressing left key 1 time. So to Windows, it's apparently 1 character. The SQL Server, it's 2 characters. So to remedy this, we added a whole new set of collations that is the _SC collations. You know about underscore, accent insensitive, sensitive, case sensitive, insensitive, and so on. So we added also SC, which is surrogate characters. That is support for surrogate characters, which is basically UTF-16. So just to show this, I can now say collate as Finnish, Swedish, CI, AS, SC, for example. No? Oh. No? What is wrong here? Finnish, Swedish? Let's do. Okay, there's case insensitive, accent insensitive. That is wrong. I can't hear you. And just so you know, we put all of these SC ones under the 100 collation version. Yeah, there we go. Okay, just checking that everyone. So clear now to everyone, it's under 100, okay? Good. There we go. So you should definitely, going forward, when you move over to Denali, always use the _SC collations. The problem isn't that, again, like you saw, that we don't corrupt data. So we can take in UCS2, in the old collations, we will happily take the character in, we'll store it, we'll give it back to you. The only problem is when you use string functions. So len, maybe not too bad, right? But if you do substring left, right, and these guys, then we'll happily cut one of these guys in half. So that's where you definitely want to use the _SC collations. Then we added support for sequence generators. So sequence generators is basically a new database object that is the equivalent, if you will, of taking the identity property out of the column and making it its own object. So it's a state machine that keeps numbers, basically. We can generate sequential integer numbers. It's also ANSI standard compliant with some extension that you'll see. This is a simple example. So I create my sequence, just any database object. It supports all of the integer data types up to decimal 38,0. You can use user-defined data types as well, as long as they're integer type based, right? So everything from tiny int. I know someone will argue that bit is also integer type, but so not bit, but tiny int and up, you can use with the sequence objects. And then you can basically specify similar properties to that you have on the identity property. It's slightly richer. So I can say, hey, create my sequence, start at 10, increment by -2, if you want to. Min value, that is, don't go lower than -1,000. Max value, don't go higher than 20,000. Cycle means whenever it hits min or max value, it will just wrap around to min or max value, depending on if it's ascending or descending sequence. And then cache. So there is an interesting difference between sequence generators and identity properties. With identity properties, we always write whatever you generate, the values you generate, always get written to a table, right? So that is, if you have heaps of inserts going on, and someone pulls the plug on the server goes down, restart the server, we just have to look in the transaction logs to find out what was the last identity value, right? Because each table that has an identity value that does inserts will be able to see the identity value generated, right? So we can always find it there. This means that with identity property, we never have to, once you generate a value, we never have to write it to disk because we know it will always be written as part of the insert, right? And if the insert never happened, when you pulled the plug, it wasn't committed, that's all fine, right? Because it got rolled back. Sequence generators are not the same, because a sequence generator I can just use in any select statement. So create a simple sequence. So next value 4, that's the function name that you'll use to generate the sequence values. And as you can see, it also by default starts at the beginning of the type. And you can also see that the default type for a sequence is big int. So what if I don't want it to start there? Well, we can create a new one and say start with 1. So now it's different though, right? Because if I run this select statement, I don't write anything to disk, but yet I use values from the sequence. Now imagine you take this result set, you know these values that the sequence is generating are unique, so you use them on the client side to populate a text file, some XML file, something, right? You know this is my identity, and then later you import it into the database, trusting that these values are unique. So what happens now if I run this select query and someone pulls the plug on the server? When we restart, if we don't write to disk, you will get duplicates, right? Because we wouldn't know which values we had actually written to or sent to you. So we restarted, that's whatever time We store the metadata, and you will get duplicate values. So we can't do that. That is why you have the cache option. So by default, cache in a sequence generator is, I don't remember, I think it's 50 or so. We don't actually publish the value. Which means that every time you use the sequence generator, if we haven't allocated any values, then we grab whatever the cache size is, put just the number in memory, right? This was the start, and this is how many values I have. And then we use it from there. Every time you exhaust this, that's when we write it to the system tables, right? And persist it. So when you restart the server, you may get gaps, right? If the server crashed, if you pull the plug on the server, restarts, you may have a gap in your sequence just because of this. It's the same as with identity if you do rollbacks, right? If you do rollbacks for identity property, then you would have gaps. If you absolutely can't handle gaps, I would argue if you can't handle gaps, sequence generators are not for you, right? They're very useful for generating unique values. You probably don't want to use them to generate invoice numbers, for example. Right? Unique keys, but not the number itself. So then you can say no cache. But if you say no cache, performance will not be super, right? Because every call to next value 4, for every row in that result set I showed you, we would actually have to write to disk. So next value 4. Again, it generates a predictable number of values. So this is actually quite problematic. So in my query, select next value 4. That sounds fine. What if we change the query slightly? And then just say, hey, where next value 4 is greater than 2? How many times will we evaluate this now? Don't know. Okay? So as you can see, depending on where I put it in the query, it would be very hard for us to guarantee a predictable number of values was generated. It would be odd for you, right? You run a select statement, you get one value back, and then we used 2 million sequence values just because we put it in a specific place in the plan, and it could use many times, right? So in this way, next value 4 is a very special function. It's a side-effecting function. And therefore, we only allow it in certain places. So, for example, if I try to execute this, the engine will get upset and say, no. Please, don't put this in top, over, output, on, where, group by, having, or order by clauses. Because that will give you an unpredictable number of values back. Okay? So then, how do we actually support sorting? What if I actually care about the row order that I get back? We support the over clause on top of next value 4. And this is the extension to the ANSI standard. So ANSI standard does not support the over clause on next value 4. We do. And this is because you may want to generate these values based on an order, right? For example, make sure that my order IDs are, the newer the order, the higher the order ID. Seems useful. So then you would use the over clause. And if you use that, now you can sort the result set. So I'll say over, order by language ID. And now I can say order by something else here if I would like to. So if you don't put an over order by clause, we actually don't allow you to order by the result set either. And that is because you may think that you may have thought that the order by clause was connected to the next value 4 statement, which it isn't. So we support ordering as long as you put the over clause in. And now I can use multiple sequence generators. What happens if I use the same here? Well, we generate a per row constant. So both of these next value 4 calls will generate the same value. Otherwise, it would be quite complicated to come up with lots of expressions where you actually have to generate these, or expressions where you have to reuse the value. And because of this predictable number of values thing, we also don't allow it in subqueries. And that's also a reason why we have this per row constant. This is all according to ANSI standard. Actually, SQL Server supports next value 4 in more queries than any other database engine, but we only support it where we can guarantee you the number of values generated. And it should be easy, right? For a select statement, number of values we generate is equal to number of rows we return, right? Per sequence. For an update, it's equal to number of rows you actually update. For an insert, number of rows you insert. And delete, we don't support sequence, right? Or next value for. We also support it in default constraints, which I don't think any other vendor does. So this makes it a very nice replacement for identity property. Why would this be useful? Well, for the identity property, it's first it's per table, right? One per table. And you also have lots of restrictions on the identity property. For example, you can't remove it. It's also unique only for that table. So it may be useful for you to have a set of tables that actually have a unique key across them. Now it's easy, right? Just create a sequence and the default next value for that sequence for each of the tables, and you're good. Now you also have a central place where it's easy to go alter sequence, restart, set new min max value. The only thing we don't allow you to alter on the sequence is the data type. So data type is whatever you created it with. And the other thing that's interesting is this SP sequence get range store procedure. So this is more for example, data warehouse scenario. So I want to generate a unique key before I actually insert into the database. Right? You want to prep lots of things before you actually do the import. Now with SP sequence get range, you can ask the server for a range, and you just say, hey, give me from sequence name, S2, range size, give me 100,000, and then range first value. And then we have an output parameter which returns the first value. So why do we return SQL variant here? It's just because this store procedure may return different types, right? There you go. So now every time I run this, we grab 100 values. And obviously, if you grab 1 billion, it's equally fast. It's just a calculation. So this is really, really useful if you want to, also if you want to guarantee uniqueness, for example, across scale-out domains, if you will. Then you can just say, okay, grab me from the central repository, grab me 1 billion values, and then I'll give it to this sequence over here, right, in this server, and I'll give the next billion to this server over here. So now you can guarantee a uniqueness across those. The other thing is improved error handling. So how many people have used try-catch in T-SQL? Okay, most of you, good. So this, now, then we have the error handling quiz. If anyone happens to have seen it before, you are not allowed to answer. I remember everyone who has seen it. So the question is basically, if I execute whatever batch that's coming up here, will I get just the error message back to the client, or will I get both the error message and hello? So for the first one here, I say raise roar. Note it's not raise error, right? It's raise roar. There's an E missing. Raise roar, error, severity level 10, or this magic integer 10, and next integer 1, and then I say print hello. Actually, I think, so raise error, it's actually, so we can spell at Microsoft. This is from previous company. That's why it has only one E. I suspect raise error is IntelliSense of the 80s. So what would this return? Just error or error and hello? Both. Yes, it will return both. because raise roar actually just sends a message to the client. And I'll test it shortly. And then what happens if I make this integer bigger? 16. Just the error? Okay, let's have a look. Raise error. First we do with 10. So we got both back. 16. Ooh, we still get both. Notice, however, that we changed color. Error is now red. It used to be black. So the the first integer in raise roar is to set the color of the error message. Currently we have red and black. Not in Denali, we will not have blue, but blue is coming in a future release. So what about 20? So 20, and there are variations of that. I won't jump back and forth. So 20 actually forces you to write this to the event log. And if you use 20 or higher, we will cut your connection. But because I forgot to put with log there, it will actually not cut my connection. I will get a different error message saying, complaining about, oh, you didn't put with log. And then if I use with log, then we will actually cut connection. So let's see here. Now 20. First we can try this. Only severity levels greater than 18, blah, blah, blah. With log. Oof. Yes. Now it actually changed control flow and did not execute hello. But it went pretty far, right? It actually cut the connection. So, okay, so now we understand fine. Raise roar does not change control flow unless I go and put the integer value 20 in there and add this with log thing that we write to the error log every time I run it, then it will change control flow. All sounds fine. What happens now if I use this in combination with try catch? So we have the 10 guide. In SP1, and then let's do SP2, where we do 16. Okay, so works as expected, right? Did not change control flow, always error and hello. Okay, what happens if we do try and catch here? So put the try block and a catch block. First we do SP1. Everything is fine. Error and hello. Now let's try SP2. Ooh, I don't get anything back because raise roar 11 severity level, this integer 11 and up, are considered errors. So in try context, we will move you to the catch block. So whenever it executed raise roar, it will move you to the catch block and then continue within the catch block, right? The problem now is that my store procedure, when I executed it without try catch, worked just fine, right? Sent the error message, then it did rollback, for example. It's very common to see raise roar and then rollback. So sent the error message and then rolled back. Now when I dynamically nested this in a try block, all of the sudden raise error changed control flow when it didn't used to. So this is obviously problematic. So this means for anything pre-Denali, you should always make sure, you should always consider raise roar that it could change control flow. Because someone could put your store procedure, even if you don't use try catch, someone could use your store procedure from within a try block. And then all of a sudden it behaves differently, right? So instead of doing this, we thought long and hard about this and decided to implement throw in T-SQL. Notice we even got the spelling right. It's T-H-R-O-W. It's also shorter than raise roar. It's very practical. Good statement. So what does throw do? Well, it does exactly what you would expect. It's basically raise roar with a severity of 16 that always aborts the batch. Okay? So we have a couple of different error actions in SQL Server. You have none, which is basically no error happened, right? Everything is fine. Statement abort, which is the most common error action. If you imagine you have an insert that fails, that aborts only that statement. It still continues after the insert, right? And it also doesn't roll back the outer transaction. It only rolls back the insert that failed if you don't use set transact abort on. Then we have scope abort, which is uncommon, but it basically aborts the current scope, that is the current level in the call stack. So aborts the current module, store procedure if you will, and exits and continues just after the store procedure was invoked. Batch abort, which is what throw does, which just aborts current batch and does not continue execution unless you catch it in a catch block, right? If you catch it, then it continues within the catch block, just like any other language. And then connection abort, which aborts the connection. So first of all, let's just try this with throw instead. With throw, I have to supply an error number. There is no severity level to supply because it's always 16. So now we see we throw the error, we aborted the batch, no confusion, right? So let's try this here in the try block. Works as expected there as well. What if I want to rethrow that error? Well, you just execute throw with no arguments, and then you rethrow whatever you had. And obviously, you can do other things in the catch block. You could do something logging or something in the catch block and then throw. But as soon as you throw, it again aborts the batch, goes up the call stack looking for catch blocks to enter, right? Note that it does not have any effect on the transaction. So if you have an open transaction, throw will not roll back that transaction, which makes sense. If you think about it, if your transaction is started on the client side, right? You start transaction and then you execute a few batches and then you're done. Then you don't want the throw statement to invalidate your transaction. That's up to the client to decide if it wants to roll back or not. So throw does not invalidate your transaction unless you use set transact abort on. So if I do this, now throw will roll back my transaction, right? But if I use transact abort off, which is default, then it will not. Still no questions? Then we have some improvements to dynamic SQL in Denali. So the execute statement, so you can execute a function, you can execute store procedures, you have different types of store procedures, extended store procedures, which are deprecated. You have CLR procedures, T-SQL procedures. And if you use, and you have dynamic SQL, right, which is just execute a string containing SQL, or execute, SP execute SQL containing a string containing SQL. If you do that, there are reasons why you may want to restrict what actually gets sent back. You may want to know what we actually send back to the client. And that's why we've added a contract on top of the execute statement. So now you can say execute, blah, blah, with result sets. And then you can define exactly what must be returned by this execute statement. If it doesn't return exactly what you tell it to, we will fail the statement. We will not roll back, right? But we'll fail the statement. You can also say execute, and it should not return anything, so result set's none. And you can also specify, as you can see in the syntax here, you can say, hey, result set should be equal to this view over here or this table over here. And if the types, so what happens when we align these result sets? So the types have to be explicitly castable, right? So we'll try to cast to whatever type you specify. If you say integer and the tiny int comes, we'll try to cast to integer. So we don't force you to be exact. We also replace, rename, right? So if you say, hey, the column name should be price, and a column called money or something comes back, we'll actually rename it to price. So here's an example. Execute this T-SQL with result sets. And here I specify only one result set. So let's take a quick peek. And for simplicity, I'll just put the string in here. So select 1, comma, hey. With result sets. So notice it's plural, right? I can specify all result sets being returned. So first, let's just specify one. ID int, text, and varchar 10. It works fine. So we get an int, and we get guaranteed, and varchar 10, and we get the name specified. What happens if I have a column too many here? Then we'll fail the statement saying, whatever you try to execute is not compatible with the result set you specified. I'd like to point out this is not, at any rate, a protection against SQL injection attacks. Right? You should not view it that way. It's a useful way to guarantee result sets to have a certain shape. Right? It may mitigate SQL injection at some point, but you should absolutely not view it that way. It's very useful to say that whatever gets executed, I want to return in this shape. And if it doesn't come in exactly that shape, I want to be notified. What happens if I add another result set here? So now it gets upset and says, oh, okay. So now it sent the first result set, and then it noticed, hey, you told me there were supposed to be 2 result sets. I only got 1. So then it throws an exception. Right? So these are a guarantee that you should get first this result set that has exactly this shape, then you should get the other one which has exactly that shape. So this is not an either or, right? Either this one or that one. It's these exact 2 result sets in this exact order. This is somewhat similar to having kind of an interface on a dynamic, an inline interface on a dynamic SQL execution. And I can also, as I mentioned, specify result sets none, and now it gets upset because, hey, you told me there were supposed to be no result sets, and anyways, you keep giving me result sets. So you can definitely use read result sets to guarantee how the data should look that comes back. And this can be very, very useful, as it can be cumbersome to understand exactly, if you create an expression, for example, what data type is this expression? Will it come back as an int, tiny int, big int? Right? If you say this column times this column divided by this column. So if you use execute as, you can allow the statement to get executed but force a specific type. Instead of trying to inject a cast into this select statement gets generated, or try to wrap it in, for example, a subquery, right? And here we can see examples. So, no, this we'll actually get back to. Then we added a set of scalar functions that are extremely useful. So first of all, a new conversion function called try-convert. So what is try-convert? Well, it's very similar to, you have try-parse in .NET. So let's say I do, hey, convert to an integer, hey. If anyone wonders, hey is hello in Swedish. So it said, no. Hey, definitely not an integer. If I say try convert, I'll get null back. So that is, if the conversion fails, you get null returned. It's as simple as that. It's very, very useful. Through this now, I can have a query, for example, say, hey, select from sysmessages where try convert message, I think. No? Message to integer is not null. Text. So very easily, give me all of the rows in the sysmessages table where the text is convertible to an integer. So now all of a sudden, you have a very flexible way of getting something like is numeric or is something, right? We have also added something else that gets you even more control, but this is definitely very, very, very useful. The other thing here you see is exactly that. So the format method, very similar to string format in .NET, and it actually uses .NET infrastructure behind the scenes. So format say, hey, take this value, whatever type it is, format it using this picture string, and also optionally using a specific culture, and then we'll give you that value back as a string. And parse is the opposite of that, right? So take this string, use this particular culture to parse it, and give me the value back. And try parse is the same basically as try convert. If it fails, you give you null back. So for example, we can say select format sysdatetime as a long date using US culture. Monday, May 16, okay? Using Swedish culture. Den 16 maj 2011. Perfect. Very, very easy way to format a string, or typically use it for dates and numbers, right? So you can also say, hey, take this number, this price column, and format it using, German culture or Japanese culture. And the opposite being parse. So I can now say parse this thing as datetime using Swedish culture. And it returns the datetime. And obviously it works for, parse this number as decimal or as integer or as float using this particular culture. And obviously if I have something weird in here, will fail, whereas try parse with something weird will return null. So fairly simple functions, extremely useful. And also format takes any type of picture string. So I can also do, for example, this year, Tobias, no, T means something. Let's try Tobias, month, day. Oh, okay. S means something, yeah. Anyway, you get the drift, right? So very easy now to format this particular type as a string using a specific picture string. And again, the picture string, the YYY blah, 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 is exactly the same implementation as in .NET Framework. One difference is that we also support the full decimal type of SQL Server. So .NET supports up to a precision of 29, I believe, in the decimal type. That is, you can have 29 digits in a decimal number in .NET, in system decimal. SQL Server supports up to 38. So we also support all of these up to 38. So it has full fidelity with the T-SQL or SQL Server type system. The other ones here are if, or if, which is function I guess many of you remember from VBA, whatnot. So if this Boolean expression is true, return the true value, otherwise return the false value. This is something you can easily write today in T-SQL using the case function, right? The case expression. This is just a simplified way. So people who are used to using the if function can use it in SQL. We actually will normalize this down to a case expression. So it is actually the case statement being executed. It's just syntactic sugar for people who like using if. Choose, same thing. Basically grab the index from this list of values. So if I say 2, it will return the second value there, so val2, for example. And concat is also interesting. Concat is concatenation of strings. The only difference is that concat ignores nulls. So it concat this, comma this, comma this, comma this. If there are any null values in there, we treat them as empty strings. And that is the specific use of concat. So just concatenate strings, ignore nulls. Note that concat is not an aggregate function, right? So you can't say select concat this column and you get, a string, comma separated or something of these values in that column. It's for scalar values. So concat this, comma this, comma this. Yep, question? Oh, so the question is, what if basically the question is, what if there are different types in the list? We'll throw an exception if we can't cast them so that they're compatible. It has to return one, the same type. Yes, exactly. So the question is, what if I want to force the type? Yes, you have to include a convert in the list of values. Another thing we also added is support for very interesting aggregations and interesting extensions to the over clause. Itzik Bengam will be talking about this when? On Wednesday. So make sure to attend his session. It should be really, really interesting. I'll just show you 1 or 2 extensions that we added that are commonly requested and very useful. And he'll get into more additions in T-SQL. That's basically the first and last value. So I can say, hey, give me the first value of language ID based on sort of severity, let's say. Or let's say just first value of text sorted by language ID. And also give me the last value. Let's just get... Ooh, there we go. The service account is out. Maybe not the best example query. At any rate, first value will return always the first value instead of min-max, for example. Min-max are based on the sorting of the type itself. Here I can say, hey, give me the first value of text based on sorted by language ID. So wherever language ID is the lowest, that will be the text that I get, right? And wherever language ID is the highest value, largest value, that's the other text I'll get. So first and last value, often you try to get at it with min and max, which is actually often hard since you want it based on separate columns, and then you have to use a subquery with a top. A question? Yes, good question. No, wait, it won't. No. Answer is no. Don't need to try. Yeah, got me confused there. Okay, because it, yeah, we can chat about that offline. And then the last set of functions is these guys. EOMonth is a common Excel function. EOMonth returns the end of the month for the supplied datetime value. So if I give you, 15th of February, it will give you either 28th or 29th of February, depending on which year you're in. You give it March, it'll give you the end of March, end of April, and so on. So very practical, simple function, just gives you the end of the month. And then we have all of these constructor-like functions. So date from parts, time from parts, datetime from parts, small datetime from parts, datetime2 from parts, small datetime from parts, yeah, I already said that. Datetime offset from parts also, although it's not listed. So all it is a function that breaks the datetime value into basically integers, and then you just supply the values. And then you get that specific instance back that you supply the values for. You may disagree with the whole from parts name. It was difficult coming up with a name. It would have been nice to just be able to have the date or time, so the type name itself. Unfortunately, we can't parse that. So we had to add something, so from parts sounded good enough. And it's also fairly common, right? Typically today, if you want to put in a constant of a number, of a date, you create a string and then you cast that to the date. Now instead of using a string, you can easily now use integers, which makes lots of things much easier, and creating formats of strings and whatnot. So, last thing I have is something we call robust result set metadata discovery. Very fancy. So the previous version of this was called set FMT only on. You can really just try it out, right? Set FMT only on versus robust metadata discovery or robust result set metadata discovery. Much, much cooler, right? Huge difference. More characters and everything. So what does this actually mean? What is it useful for? Set FMT only on is a very simple flag in the engine that you flip, and what it does is it executes statements without actually executing them. It only grabs the metadata that would be returned and sends an empty result set to the client. Okay? And why would you ever want an empty result set? So it's fairly common in, for example, if you want to create a report designer, right? You want to be able to put a query in your report designer, and now you want to know, okay, I have the query, what are the columns available to me, right? What is it that I could actually use in my report when I design it? So now you have the choice of executing the query. And if I execute the query may take an hour to execute, right? The query may even have side effects, right? It might be an update with an output clause, for example. So what if you just want to know what is the results that I would get back were I to execute the statement? That's what it's about. Another use case might be you use the query to automatically generate a form, right? Where you could input data. Now you just want to get the metadata, you don't want to execute the query. So let's try this. So select, let's do top. So we have select from sysmessages, sysobjects. So if I just execute this, I get the data back, right? If I instead execute it in this set FMT only context, I get empty result sets back. Oh, okay, this looks fine, right? I get both result sets, this is correct. Okay, let's do if, 1 is less than 2, do this, else do that. I still get both back. This is odd, right? I should get one of them. I don't know really which. So set FMT only on, the only thing that does is it basically ignores control flow. It goes into all possible control flow paths once. So if there's a while loop, for example, we'll enter the while loop once, do whatever is in there, and return back. You can also trick FMT only. So since there are problems with this, as you can see now, I may get either or of these, and I want to maybe say, give me this back. What if I do if, let's keep this guy, if 1 is equal to 2, sorry. That's not very frequently, right? Only set FMT only will go into that if statement, right? It's only true for FMT only. So FMT only enters it, flips the bit, and now all of a sudden I'm in real execution mode again, which is pretty scary, right? Because obviously the client wanted to execute the batch or stored procedure and just get the metadata, and the stored procedure batch contained something to turn FMT only off. And you can get fancy here as well, right? So declare is FMT bit. So by default, we're not in FMT only mode, right? But if I go into this guy, we do set is FMT true. So now I can even detect, aha, this batch or stored procedure was actually started under FMT only mode, because that's the only time this bit would ever get flipped, right? So it's a bit weird. Or not just a bit, it's silly really, right? And this has existed in SQL Server for a long time. Instead of doing this, we want to give you something robust, where you can give us a batch or stored procedure, and we will actually analyze this for you, and we will tell you what would be returned if you were to execute this. So first of all, we don't want to use a set statement, because you just saw why, right? Set FMT only is scary because someone could turn it off. So instead of doing a set statement, it's now within a stored procedure. And why? Yeah, sadly is broken. Yeah, bad. So first, let's just try this guy to see what happens. We copy this. SP describe first result set. So why first? Well, it turns out it's really hard for us to tell you anything that makes sense for anything but the first result set. If you imagine a while loop, right, how would we know, how would we be able to say this is the first result set, this will be the second, this will be the third, right? We could do extensions to this later and say, okay, as long as there are no such cases, we can give you this will be the first result set, this is the second, this is the third. But in Denali, this is what we're adding, which is give me what would be the first result set from this batch. And this batch, what would be the first result set? It's either sys messages or sys objects, right? So we'll tell you, yeah, really? The metadata could not be determined because the statement blah is not compatible with the statement blah, right? Because these do not contain compatible metadata. So that's basically what this system procedure does, is we analyze all possible first result sets and compare their metadata. And if the metadata is the same, according to what I'll just soon tell you, then we'll say this is what you'll get back. If they're different, we'll say these two statements are not compatible. So what has to be the same? Well, here we're much, much stricter than this execute with result sets. Because if I tell you an integer, you are expecting to get 4 bytes there. So I better not give you a big int later, right? Or even a small int later. So we compare the types. The types have to be exactly the same, including collation. The one difference is for variable length types. That is, varchar 10 and varchar 20 will just say varchar 20, right? We'll just give you the bigger one. That's all fair. Nullability, if there are different nullability on the columns, we'll just say it's nullable, right? And if there are different names of the columns, one is called price, one is called money, we'll just say we don't know the name. Those three are basically the things that could happen to you. So we summarize this. No, wait, we'll get back to that. We summarize this like this. So this is Adrian the dev, who wanted it to be very, very, very correct. This is the guarantee that we give. We use it slightly simplified. So basically, if you execute SP describe first result set on a batch, It analyzes the batch, and it gives you metadata back. We guarantee that when you actually go and execute that same batch, as long as no schema changes were done on the server, right, the same schema applies, you will either get a result set that is compatible with M that you got back, right, or you'll get nothing back, because it's a very common pattern to do if blah return, right? We don't want to fail that. Or you'll get an error message, because obviously we can't guarantee that you'll not get an error message. So you'll get whatever we told you, plus or nothing, or an error. So if we move back to this guy, perfect. And for example, now we have the two different tables, and I do object ID here, and let's say message ID here. Now they're compatible, and we'll just say, hey, you'll get a column back, which I don't know the name of, but for sure you'll get an integer when you go and execute this. So we look at all possible control flow paths. That is, if you have an insert statement on a table that contains triggers, we will go in and evaluate all of the triggers. So all possible control flow paths we look at. The other thing that you can also do is, which is very interesting, is you can use this to analyze your existing stored procedures. So, for example, if I say select from sys.procedures, it's not that many. Let's just go with those. We can say outer apply, and we added the DMF for this. So sys.dm exec describe first result set for object p.object ID, and then 1, I think. Then let's say p.name. So now we actually executed this SP describe first result set against every stored procedure in this database and analyzed what the result sets were. Neither one of these actually have a select statement. So we just get them back. And here we say, oh, sorry, for this one, the metadata could not be determined because there are no code paths that reach the end of the batch. Ah, interesting. So we have throw statement in here. But as you saw, we go in and analyze each and every one of your stored procedures, which is very interesting if you want to build a simple program that, for example, returns, these are all of the result sets returned by all of my stored procedures. Now you can very easily query that, kind of like you can with views already, right, with sys views and sys columns. The other thing is SP describe undeclared parameters, which we refer to as the Jedi mind trick. That is, when SQL Server will look at your batch and go, I think you mean integer. Very, very interesting. So basically, what if you have a query? Let's go back to the report designer example. You have your query, select, blah, 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 and then you have an argument in there, where price equals at price. Now it would be interesting for the report designer to figure out this at price thing you're talking about sounds all very good. What type is it? Right? What should I show the user? Should I show the user a text box that allows him to type any string? Is it a number? Is it a date? What is this at price thing? Is even parsing it, are there any at prices in there? That's what the SP describe undeclared parameters will do. So let's steal this guy. And as it's called undeclared parameters, you can also give it a list of these are my already declared parameters. I already decided at price is integer, so don't go bother giving me anything for that. Right? So undeclared parameters, and then let's go with sysObject, where object ID equals object ID. So what is the type of object ID? And here we suggest integer. Okay, what if we do times 2 divided by 100? This seems like a numeric 17.6 to me. That is, this is just a suggestion, right? There's no guarantee that this is the right type that the user would like to send. But it is a good enough suggestion for you. It's the thought. So give us any expression and we'll figure out a type that will work for you. But as long as it's not just object ID. So for example, or just a parameter. Let's say I also put one up here, @x. What is the type of @x? Obviously, we can't really figure it out because it stands there all by itself. So we say the parameter type for x cannot be uniquely deduced. And this one we're changing. You know, you could go with either SQL variant or XML. If Michael Rees is in the room, XML is good for everything. Yeah, so we'll change this error message to just say, hey, we don't know. Could be either int, you know, either int or bit would also work, right? I have no idea. Could be SQL variant or XML as well. And here are just examples of where we do the comparisons. And as you can see on the third line item there, FMT only would always go with mvarchar 50 because that's the first. You'll get both, but most programs that use FMT only will go with the first. So it'll go with 50. We'll tell you the correct 120, right? And the second one, it's either an int or a varchar for the first column, and we'll just say, hey, don't know. Same if the number of columns differ. Hey, this one has 2 columns, this one has 3 columns. We'll just say, there's different number of columns. We can't tell you what to go with. So this is why we call it robust metadata discovery. You can argue FMT only always works. It's just that the metadata you get back is crap. This much better since you can actually trust it. So with that, I'm done. Please feel free to ask questions. I'll stick around here also after the talk. Thank you.